Hi, and welcome back. This is Pankaj here. Of late, I've been making videos on probability and relations and functions and permutation and combinations and inverse trigonometry. So while I was making this video, I thought that, why don't I make a video on linear programming? Yes. Well, linear programming is a topic or a chapter that 12th standard CBSE learns. Okay. And so does 12th ISE. Okay, so both of the syllabuses has linear programming in the 12th. 12th ISE has that in the section C, and that's an optional for 12th ISE, whereas it's not optional for 12th CBSE. Now, before I can actually pick up linear programming and start explaining that to you, you need to know very basics of mathematics. Okay, what am I talking about? You might be actually surprised as to what I'm going to do today. I'm going to be actually talking about natural numbers, yes, real numbers, what's a rational number. Okay, these are the things that I'm going to be talking about in this video. Do not discontinue with this video. Complete this video because you're going to be learning something very important. Okay, how is it going to be useful to you? You will know that by the end of this video. Okay, and once I've done with a small introduction on these number systems, I'm also going to be talking about solution set and replacement set. Okay, what is meant by a solution set and what is meant by a replacement set? That's something that we're going to discover. Okay, now who learns this? This is learned in 11th CBSE. Well, you don't actually learn it as a solution set and replacement set, but that's something that you actually learn. And well, for ISE students, you learn this in 10th ICSE. Okay, in 10th ICSE, you learn about solution set and replacement set and how to deal with that when it's a real number and a natural number. It's a very simple concept. I'm going to explain that to you. Okay, so all these things, gradually moves into linear inequalities. Okay, so that's what we are trying to learn, linear inequalities, and probably later on you can also talk about quadratic inequalities. Now, once we understand linear inequalities and quadratic inequalities, we will be ready to learn linear programming. Okay, so what is linear programming? This is a very important concept which is applicable in operational research. Okay, and what is it? It's a major concept in mathematics. It's a very interesting and an amazing concept that you have in mathematics. And how do you learn that? You learn that by knowing all these basic things about mathematics. Okay, what is it? Natural numbers, real numbers, solution set, replacement set, linear inequalities, and then comes operational research. Basically, we're talking about linear programming problem here. Okay. And in linear inequalities, we have two types. One is in one variable, and then we have it in two variables. We will look at how to solve this linear inequalities in one variable and also in two variables. I'll try to cover as much as possible in this video. If not possible, I'll have to make more videos on the entire section. Basically, this video is going to help you to build up to linear programming problem, which is in your 12th. Okay, fine. With that being said, let's just start understanding the number system. All right. So, well, the things that I'm going to be talking about is something that you already know, and if you have actually referred to my videos, I've always been telling you that the difference between this R, which is the relationship R, and this R, which is the relationship real numbers R. There's going to be a slight line right next to R. Okay, so now I'm going to talk about natural numbers. I'm going to put the line right next to it. Natural numbers are numbers which start with the 1, 2, 3, and the 4 and goes on, isn't it? Now this is what it is for CBSE and ICSE students. Whereas for IGCSE students, for IGCSE and IB A levels, they learn natural numbers with a 0. They do not have a concept of whole numbers. So please do not confuse yourself. If you are an IGCSE student, for you natural numbers starts with a 0. Whereas for students from CBSE or ISE or ICSE, you don't start with a 0, you start with a 1. Okay, so that's my natural numbers, and then I have whole numbers. Whole numbers are starting from 0, 1, 2, 3, and so on. And then I have my rational numbers, which is going to be, oh no, before rational numbers I have integers. Before rational numbers I have integers. Let's take care of that, which is 0 plus or minus 1 plus or minus 2 plus or minus 3, and it goes on. Okay, and then I have my rational numbers. My rational numbers are of the form P by Q, where Q is not equal to 0 and P comma Q belongs to integers. Yeah, that's the definition for rational numbers. Okay, well, I always ask this question to my students when I'm actually teaching them about rational numbers. The question is this: 2 by 3. Well, this is a rational number, isn't it? Because P comma Q belongs to integers. So 2 belongs to integer, 3 belongs to integer, which basically means that this is a rational number. Well, is it a fraction? Yes, it is also a fraction. So what should I call this as? Should I call this as a rational number or a fraction? I do not know. Is it both? Yes, it is both. Okay. So now let me ask you this. What about minus 1 by 2? Is this a fraction or a rational number? It is a rational number only. It is not a fraction. Why is it not a fraction? Because if I think about the definition of a fraction, what does it say? A fraction is a part of a whole. Okay, so if I have a part which has been divided into 8 equal parts, then I can say that these 2 parts is out of 8 parts. So that's my fraction. So the part can never be a negative, right? So a fraction is a part of a rational number, but not all rational numbers are a fraction. Okay, fine. So there are going to be numbers which cannot be represented in the form P by Q. Those type of numbers are irrationals. Which is not a rational, is an irrational, and everything put together becomes my real number. Okay, now I'm going to explain the same thing in a different way altogether. I'm going to try and explain this in 3 different ways actually. I just want to make sure that you get the concept correctly, because we're going to be doing a lot more of these. I want you to make sure that you have this clear-cut idea about what these are. Okay, perfect. So let's look at this on the number line. All right, let's look at this on the number line. Let's say this is the number line here. Okay, that's my number line, and let's say this is the 0, 1, 2, 3, and this is 4. Then I have a minus 1 here, the minus 2 here, minus 3 here, and a minus 4 over here. Now when I'm talking about natural numbers, I'm going to use a different color for natural numbers. Okay, these points are my natural numbers. It goes on, isn't it? 4, 5, and so on. It goes on further. Okay, so what are my whole numbers? Okay, for my whole numbers I'm going to use a different color again. So these points are my whole numbers, isn't it? Okay, what about my integers? Okay, again a different color. Fine, so these are all my integers. Okay, which basically means that minus 4, minus 5, minus 6, and this also 4, 5, and 6, and so on and so forth. These are my integers. Now when I come to rational numbers, okay, let's look at this. In between these integers there are these decimals. All these decimals like 0.5 and 0.2 and so on and so forth. Now those are my rationals, but not all of them. Okay, not all of them. So somewhere here might be my irrationals. Now let me explain irrationals in a different way. Barring those things, the remaining stuff will be my rational number. Okay, now to understand irrational numbers, let's look at decimals. I know these are, connected. ICSE students, you learn this in your 9th standard. Okay, let's see what I'm talking about. What are the two types of decimal expansions that we have? We have terminating, and then I have a non-terminating. Something like a 2.75. Okay, this is a terminating decimal, isn't it? And then I have a 2.3433333. It goes on. So that's a non-terminating decimal. Okay? So there's no more classification for terminating, but then non-terminating can be of two types. Non-terminating can be of two types. What are they? Either they can be repeating, which otherwise is called as recurring, or they can be a non-repeating, which otherwise is called as a non-recurring decimal. Okay, so what does this help us to do? If you look at this section, which is non-recurring and not terminating decimal, these are my irrationals. Okay, what am I talking about? So something like a 1.1425317. Look at this. This is not going to terminate, nor is going to recur, or not this 2 is going to repeat itself again and again, nor a bunch of decimals is going to repeat itself. These kind of decimals are going to be called as irrational numbers. Now, if you have heard of these things like root 2 is an irrational, root 3 is an irrational, yeah, I'll bring up the calculator for you. Okay, so that's the calculator. I'm going to make use of the scientific calculator. Okay, there you go. Now I'm going to do a root 2 for you. Alright, where is the root on this? There. Root 2. Okay, 2 square root. There you go. You look at that, it's not even terminating. It just goes on and on and on and on. This is not the end of it. Let me tell you that. The calculator has the capability to display only these many decimals, and that's why it's ending at 7. Otherwise, it's going to continue more, it's never going to end. So this is a irrational number. You've always heard this. Pi, which is 22 by 7, is an irrational number. There you go. Pi, this is pi, 3.14. It's never going to end, nor is it going to repeat itself. So that's a irrational number. Root of any prime number, like a root 3 or a root 5 or a root 7, root 11, all these are irrationals. Okay, so I can also plot that on the number line somewhere here, probably. Barring all these things, the remaining will be my rational numbers. Getting me? All these put together, your rationals and irrationals, everything put together becomes your real number. So this entire line is a real number, and that's why this is not just called as a number line. This is actually called as a real number line. Okay, perfect. So let's look at these things in a different way now. Okay, so you have your natural numbers, and then you have your whole numbers, and then you have your integers, and then you have your rational numbers. Now irrationals is going to be outside of all these things. Both of them put together is your real numbers. Okay, so that now gives us a clear picture of my number system. Okay, perfect. So that's a very good information that we got. It's a very small thing that to know, but very informative. Okay, we looked at the same things in 3 different ways actually. Okay, with that I'm going to stop this video. I would be taking up inequalities and inequations in the next video. I would suggest that you go ahead and watch that also. Please go ahead and subscribe, share these videos with your friends, and any comments or anything that you want to ask, please go ahead and post it onto the comment section. Thank you. Goodbye.